Καλησπέρα σε όλους. Ευχαριστούμε που ήρθατε στο τρίτο event του API Athens, το meetup στο οποίο προσπαθούμε να ενώσουμε το business και την τεχνολογία μέσα από τα APIs. Είναι το τρίτο event που κάνουμε και τυχαία σήμερα έχουμε και τρεις ομιλητές, οι οποίοι είναι εξαιρετικοί, με πολύ μεγάλη εμπειρία πάνω στα APIs και σε πολλά επίπεδα. Θα μας μιλήσει ο Στέφανο Negri από την WSO2, όπου είναι Solution Architect. Θα μας παρουσιάσει ένα use case, πώς εταιρείες τηλεπικοινωνίας αντεπεξέρχονται σε καινούργιες δυσκολίες χρησιμοποιώντας APIs και έναν API Manager. Ο Δημήτρης, ο Μaimaris από την Vodafone θα μας παρουσιάσει πώς το Solution Architecture συνδυάζεται με το API Governance. Και ο Juan Cruz θα μας παρουσιάσει κάτι πιο low level, πώς μπορείς να φτιάχνεις APIs τα οποία είναι πάρα πολύ γρήγορα σε performance. Οπότε, για να ξεκινάμε, enjoy. Να το λόγο στο Στέφανο.
Okay, thank you. Thank you very much. Thank you for inviting me at this event. I'm very happy to be here. So it took just 50 years to visit Greece, even though I'm not living far away because I'm Italian. But okay, I will try to fix this and to visit more of this country. I promised to my colleague Eleftherios, so I will do. So, yeah, just a few words about myself. As I said, Stefano Negri, I'm working for WSO2. WSO2 is a vendor company, it's an open source company, active in the API management, integration, and identity asset management. As I have an open source company with a cloud offer as well. Feel free to join our website to visit your website. So what I'm going to present today is my recent experience with our telecom customers, especially this one is a German telecom company, Telefonica Germany. I had to remove the name from the slide that I want to show you last minute because unfortunately we are not sure we have a real NDA in place, so I checked with my legal to keep it out, but that's the company, it's a huge company in Germany active in the telecom market. And my telecom experience is that many years ago, and something related to this building at this company new, because I am also proud to be one of the initially introduced enterprise application integration. As I said, I started working many years ago in a telecom company for Vodafone Italy in an enterprise application integration project. So I have some experience I want to share with you today. What I want to start with is an overview of what is, I think, the number that I collected, the discussion I had with my customers, the situation of the telecom market in Europe, which is not in a good position. I mean, there's the number that you can see. It's decreasing kind of, or stable for many years. I report some number here in Europe in 22, a decrease of 3% of the revenue of the market. And nevertheless, as you can see here, even though there is no margin increase, the amount of traffic in Europe is increasing more than 100%. So there is an increase of the consumption, of the usage of the telecom asset, and not of the revenue. This is something that the telecom company, okay, I do not want to hear you say in Italy, not teach the cat climb, because Vodafone for the telecom areas, I don't want to be the teacher in this area, but maybe if you don't recognize this current number, maybe later we can have a discussion. But this is what I found talking with the customer around Europe in the telecom sector. So there is a difficulty. So the only area which is increasing is the mobile data, but still this is not enough to generate the revenue that are needed to the investment that are behind the telecom sector. If you think about 5G, it's a huge investment that the company, at least in Italy and Germany, they are struggling to achieve. The reason are many. Probably a strong competition is the main reason. I come from Italy. As I said, in Italy we have probably something like 10, 15 operators, including the vehicle operators that have been introduced more than 10 years ago. This creates a reduction of the margin, a strong competition with the reduction of the margin. For example, for my contract in Italy is only less than 10 euro a month. So what can be a solution on this thing? What can be a way out to this situation? So the chances are to talk with my customer, to make some inquiry, and I found this survey in 2022, which was relatively recent, from IDC, and I wanted to highlight here in bold what I found the most significant sentence here. So, create a new business model. Where this business model comes from a partner-driven ecosystem, and how you can create a partner-driven ecosystem with integrating partner services with an API-driven strategy. This is exactly what Telefonica wanted to do, create extend their assets to a wider market. And we can read further, for example, Telco needs to ensure that APIs they provide are simple enough for the development partner to use and supported across heterogeneous network services. Okay, so this is what I think is. I think this is valid for every market. So in Telco, what I want to show you today is clear for some reason that I hope it will be clear here. But this is valid for every sector. Every sector has some asset capability that they can exploit with creating a partner-driven ecosystem. So at the end of the story, what Telefonica wanted to address, how Telefonica wanted to address these challenges is in two areas, I understood. One, imagine you have a cake. The cake is the telco market in Germany. You can try to increase the slice of your slice of this cake. So have more customers. Retain your customer and add your customer base. Different ways you can do that. You can introduce intelligence, improve your quality of your processes, etc. The other opportunity or the other option is to find new markets. So the cake has to be bigger, no? To create a bigger cake. Because in the first area, you have to compete with others. The bigger is your cake, your slice, the smaller is the lie of your competitor. So the other solution is find new market. Find new markets. Okay? What is, I assume, the situation of the medium telco company in Europe now? So as I said, I've been working for telecom company for many years. The situation was signed up from the IT point of view and what we call a siloed architecture. And this siloed architecture is based on different domains. Each domain is a customer base, its process, its application. And for example, I work, as I said, in the enterprise service bus project. And the challenge there was to make these applications talk in each other. But still, and not create an agile environment. I'll give you an example. I don't know if something happening here as well, but when I was working for Vodafone Italy, we had only five business releases a year. Totally not agile, not ready to create a competitive environment, to respond to the need of the customer. So that's what is the situation of a typical telecom company now or 5 years ago, depends on Germany. Telecom Germany was like this, a siloed architecture. They want to move away from simple architecture, move towards a layered architecture, API-driven, microservices oriented, parent-driven. Okay. And what they identify as a key enabler to improve their customer base or to gain get new customers was to improve customer experience. The customer journey for a telecom company is very complex. You know better than me. It involves several stages and several processes. And at the moment, we start this project in Telco Germany, all this process was completely disconnected. We disconnected each other with different customer experience based on the process, based on the customer, for example, if you want to go via web, completely different from the shop, completely different from the app mobile, a disconnected customer experience. And the objective they had is to provide a unified end-to-end customer journey to customers and agent. Also, agents are very important in the context of the market of telecom. And to create a seamless experience for customer independently of the channels. Independently of the channels, independently of the stage. Whatever the point that the customer journey was, Telefonica want to provide a seamless customer experience, web portal, mobile, or to shops. But this has eliminated from the silos architecture I mentioned before. Silos architecture was not suitable for this improvement. For different, as I said, separated application, which different customer base, each domain has its own API gateway, and or no API gateway at all. So we enter, of course, as a vendor, we are in the API management sector, we found this situation, different channels, different domains, means different API manager, different gateway or no gateway, different business logic, and different identities. All this added to a different, completely different experience. What they wanted to achieve is a target, was an API platform to expose standardized API. So for achieving that, they wanted to have a single API management, not a single API, not a single gateway, but a single centralized API management with reliable and centralized gateway. Reliable, the gateway must be reliable for obvious reasons. I mean, if you have, you can imagine the traffic that a company like Telefonica Germany can generate. It's a huge traffic, so you have to have a gateway that is reliable, scalable, suitable for each and every potential deployment. They wanted in parallel to move to cloud, to move to microservices, to move to Kubernetes. So and a gateway is suitable for each and every potential deployment. By the way, Telefonica wanted to not have a privileged cloud company, but being multi-cloud. That was another challenge. So a reliable gateway, a robust security. So a component and API manager has the capability to have, for example, an embedded identity provider, or to communicate natively with the heterogeneous identity provider, because they had different identity silos. But to provide seamless or unique customer experience, you have to have a centralized point of where identities are managed. Federation, maybe, eventually, managed centralized. So robust security with the gateway which connect with the user store or the identity provider and provide security like authorization, authentication, encryption of the data, etc. All these capabilities were mandatory to achieve this target. Analytics is also a quite important part, because to understand, to provide a good customer experience, you have to understand the customer behavior. So, yeah, manager wanted to be in a way that possible to feed their analytics component or have an embedded analytics component. And then, finally, a comprehensive development portal. The development portal is where the user connect to the portal to try out an API, search an API, try out an API. These are all facilities that make the development cycle more effective. A very important, when we talk about standardized API, it's important that an API gateway is compliant with standard. Everything should be compliant with standard. The standard you probably know this. This one is TM Forum. And we have some challenge there because the product has to handle the compatible the standard in each and every case, as in the case for errors, for example. In the fault request reply, in the fault API call, the answer should be compliant with the template that TM Forum provides. So there are all challenges that we have to face. The other area that the Telefonica want to explore is this find new markets. Find new markets means this is an example of what they find new markets in. So the traditional market for a telecom company was to sell connectivity. So to create infrastructure and connectivity asset that connected to a telecom vendor and sell connectivity to enterprise and consumer. This is the business of the telecom company. Your customer can be a consumer, can be a self, can be a company. This is exactly the market that doesn't grow. And this is exactly what they have to change in order to make the cake bigger. And how this is possible is to understand, to transform this connectivity asset or this telco asset in services and make these services consumable by internal or external developer or partner. That's the partner-driven ecosystem. Exactly. These are the partner. This is the partner-driven ecosystem I was talking about. And guess what? Transform services in usable services is an API. Okay. This the process of application. That word that I don't like, but is very common use of your internal asset or your internal service. Once you have done that, you can create your own application and sell something different than connectivity. Sell application that probably you are also doing your internally for related to the movie or for Vodafone TV, those applications that you are selling. But you can do more, so you can enable your partner to be themselves create application to sell to consumer enterprise. Or another actor that I will explain later what is it, enable aggregators to create enable this application that I want to face. This is what they wanted to achieve. What I call it, monetize your asset. As I said, this is value for each company. So in telecom, your assets are, I will show you later, okay, you know exactly what your assets are. I will remind you, location data or customer data, etc. But every sector has the same capabilities. So what are the thresholds that a telecom company has? Well, the location of a customer. A telecom company knows where a customer is, more or less approximately. He knows a lot about the identity of a customer, who he is, when he's born, etc. More about identity. He manages payment. He has some payment data because he has to pay your services. And then he knows, or he can handle everything related to the connectivity, the quality of the connectivity, of the language. And he has capability to communicate with the customer, with SMS, etc. These are the assets that you want to transform, you need to transform in services and to sell to your partner ecosystem. So these are an example of the potential use case of this asset. For example, related to connectivity, SIM swap. SIM swap is the data that maybe many of customer view, business customer view are interested in. For example, in the finance sector, a bank may be interested to understand whether a user swap this thing because it's a potential fraud. So it's something that you can sell to a finance company. Number verification for enabling what is called passwordless login or fast and secure mobile application registration, all related to the area of the customer experience, back to the customer experience. To sell to an application owner these capabilities to create applications that are more usable from a customer. The location can be used for fraud detection, can be used for hyper-precise location that could be used for example, machine-driven or robot location. Quality on demand is also the request for higher quality. So when you have a connectivity, connectivity has a certain quality, but you can increase the quality of connectivity of the users and sell these capabilities. I'm a normal user, I'm happy with the connectivity I have, but if I wanted to use, for example, gaming application, I may be interested to have a better quality of connectivity and maybe want to pay for it. So it's something that you can transform in business. And ODS, the device status, discovery edge point, what is edge point, device status, checking the device is connected or not, the network, and all the information related to the payment, care billing. You can sell the payment process to a third-party company for a seamless purchase of digital content. These are all examples of potential use cases that can be transformed. If you transform these services in API, then you can sell enhanced security for anti-fraud banking company. You can transform this asset in capability for the real-time gaming market, as I said before, productivity for enterprise, for example, video conferencing is something that a company can invest to buy and pay for better quality on the connectivity in some slot time for having a meeting with the colleagues worldwide. Extended reality, autonomous vehicles, etc. Those are all examples area that what we call network API can support. Who are the user stakeholders in this market? So we have a partner-driven ecosystem. Who can be your partner? It can be the end user itself, probably not, but the developers, yes. Developers that can create his own app. When I think about developers, I'm not thinking myself in evening developing some app, but the company that develop app. The telco operators, of course, the marketplace. The marketplace of hyperscaler are very active in this area. And so AWS has provided a lot of services based on telco capabilities. And then there are the aggregators that I mentioned before, because if you provide this kind of services, for example, the localization or quality, if I want to build an app for gaming, I want to build for users that are customers of Vodafone, Deutsche Telekom, etc. So we need an aggregator which can connect with all the potential telco providers. And then a relevant part here can play the standardization bodies. Here, Camara is the leader. Is an association of telco providers, and they create the standard of these network APIs. This is the partner ecosystem that I mentioned. What Telco Germany did, so they are active in this area. There are already some customers. There are customers in the media and entertainment sector. This is IDPR. It's a company that provides immersive, they call sporting events for them. They need quality of quality, what we call quality on demand. For a specific moment, the customer to have a better view of a sport event, they be happy to pay more to have this quality increase. Payment, so everything related to the anti-fraud, localization, SIM swap, SIM status, everything can help a payment system to detect potential fraud. Financial services, again, similar, no? Safe transaction through device location. So we already are in a situation in Telco to be able to provide, to create this partner ecosystem. Slowly, they are adding more and more customers in this area to increase their revenue. Again, here, crucial role is played by the API manager. So we look, you have to transform services to API, but then you have to manage this API. Manage API means introduce also already security, for example. When you want to expose API to a partner ecosystem, you need a strong security framework. They can know who is connecting, how often is connecting. If you want to limit rate limiting to avoid attack, authorization, encryption of the data, and analytics plays a key role to understand the behavior of a customer, trace the traffic, etc. And here you can monetize your API. You can, of course, you are creating this API, you're pushing your API in your development portal to get money. So you want to either have an embedded monetization tool or be capable to connect your API gateway or your API somehow with your bidding engine. This is something that an API manager can do. Having said that, maybe I would like to spend a few words about what has been our journey with Telefonica Germany, which started the POC in late December 29, and we went in production the year after, in 2020. We took a really short time to be up. And this is something that go in the direction that I mentioned before, to move towards a more agile solution. You need agile products, products that you can change often in a short time, that are ready to be productive in a short time. Then there was an upgrade, and then a significant step of the dimension. I mentioned before that Telefonica is not linked to any specific cluster provider. They want to be multi-cluster provider. So we have a multi-cluster deployment. When I initially mentioned centralized API gateway is partially true, because they want also to distribute the gateway flow of the API provider, cloud providers, to be closer to the cloud providers. The next important milestone that we are addressing now is monetization. Anti-monetization. So at the moment, they are collecting the data with the analytics and feeding the billing system, but they want to do something more native for API, an API-oriented monetization. That's the challenge that we are having now. Why they choose us? What are the key points that we think each buyer should consider when he consider an API tool? There are many, but I reported some of them. For example, easy and friendly configuration. Products has the ability to be configured easily, is not complex, not connected to a specific environment or structure. Transformation capabilities, security, capability to have policy, SLA management, API monitoring. These are the main area that are evaluated when an API manager tool is considered. security. I wanted to mention particularly automation, because most of the company are wanted to embed their technology in their CI/CD process. So a product that provides CLI tool or admins APIs is this aspect is mandatory. Yeah, those are the other one I want to mention is the deployment flexibility, capability and capability to be deployed on premises, SaaS, Kubernetes, different flavor, OpenShift, etc. Those are the key factor, the main area that they are interested in. So we managed to be live, as I said, relatively short period. The initial deployment was EKS by AWS, so it was the complexity was double because they want also to move towards cloud deployment and microservices deployment at the same time. So it was something new also for them. Now we have this API gateway multi-cluster. We have a centralized API management and a distributed gateway. So multi-cluster, multi-provider, and we are around more than 400 API onboarded at the moment with a traffic of more than 100 million API per month. What they get, so they definitely managed to increase the interaction with their partners, as I said before, create this partner ecosystem. Now the partners can easily access the external portal, explore the API, check the API documentation, try them out, provide feedback, get notified of changes. So there's a good interaction with their partners, so they can easily onboard new partner that I showed you before for creating new business. And this is not valid only externally for external consumers, for internal. So the whole API life cycle increased definitely. Now the time to market for onboarding a new API is 1 week. A week you can put a business change in your environment compared to what I mentioned before. Was I remember that we were doing Vodafone time. We had 5 business analysts a year. Yeah. First, adhere to standard. They can provide a clear API life cycle, standardized, can follow Camara. We can achieve a multi-cloud strategy, as I said before, because they work with different hyperscaler, but at the same time, the centralized access point that allow to avoid zone or cluster awareness complexity. And security. They can provide the same security model for all the API worldwide in the company with the capacity to work with many identity provider or to have an embedded identity provider to provide authentication, security, identity. So this is an example of what I meant for centralized, managed, and distributed runtime. So they can create as many regions they want, have a gateway in each region, and having this centralized, a single point, a single team, so that they can, now they are on Azure, they are in AWS, they are in Google, they can have also more region if they want in the future, they can scale this deployment as far as they want. Yeah, that's the end of my presentation. So as a conclusion, we have seen that the telecom market is struggling in the EU nowadays. I have Italy saying Italian, but they made some research in Italy, but it's valid for every company. I show you how APIs and API Manager are a key enabler for new business process. Yeah, I'm from WSO2, so I sponsor WSO2, but of course we have our product is WSO2 API Manager. And thanks also to us, WSO2 API Manager, Telefonica is now successfully leading a digital transformation journey. We managed to embrace new, to create new business model and create a new partner ecosystem. Yeah, so it's the end of my presentation. I will be very happy. So your feedback, especially most of you are from Vodafone here, so you are expert of the telecom area. If you have any question or any comment, feedback, you say, no, your data are not valid up to date.
Are there any questions?
Okay. So yeah, I'd like to inform you that as a WSO2, you'll have a huge conference next year in Barcelona, is WSO2 you can get the information on our website, it will be in March. I would be happy to meet you there eventually, it will be great. If you can't join the WSO2 you can connect with me with LinkedIn. You can easily find me there, and we'll be happy to connect you. Thank you very much.
Okay, thank you, Stefano, for the insightful presentation on the Telco case. And we'll stay in Telco with Dimitris Maimaris from Vodafone.
Hello from my side as well. I'm Dimitris Maimaris, one of the chapter leads of digital, I would say why I mentioned this, of the solution architects here in Vodafone. And I will explain a bit what the solution architect does in the API part of the list here in the company, which is a great part of our work. Γενικά το Open Governance είναι ένα set of standards, ας πούμε, και κάποιους κανόνες που πρέπει να έχουμε στις μεγάλες εταιρείες τουλάχιστον, γιατί είναι ένα χάος το IT, είναι πάρα πολλά τα processes, οπότε πρέπει με κάποιο τρόπο να τα κάνουμε govern. Ξέραμε ότι developers αυτή την governance αποκλείεται, βαριέμαι. It's okay, αλλά νομίζω έχει σημασία να καταλάβουμε γιατί. High level, λίγο να δούμε το definition. Άμα το χωρίσουμε σε κάποια κομμάτια, σημαντικό είναι το life cycle management, όπου μπορούμε να κάνουμε ένα πολύ καλό API management εργαλείο, που σχεδόν όλες τις εταιρείες έχουν πλέον, γιατί χωρίς αυτό δεν γίνεται. Να έχουμε design policy μες στην εταιρεία, θα σας εξηγήσω πιο μετά πώς το κάνουμε εσωτερικά. Security πολύ σημαντικό. Όσο πιο μεγάλη εταιρεία, τόσο πιο μεγάλο το impact των API που φτιάχνουμε, γιατί άμα δεν φτιάχνουμε secure, μπορεί να καταλάβετε ότι αν κάτι δεν πάει καλά, ο πελάτης μετά θα μπορεί να κάνει legal actions. Να υπάρχει ένα ecosystem στην εταιρεία, γιατί είναι πολύ μεγάλη. Και conformance compliance με regulatory, όπως σημαίνει η ΕΕ, μπορεί να έχει κάποιους κανόνες που θα πρέπει να κάνουμε govern και να είμαστε regulated. Θα εξηγήσουμε λίγο το πώς γίνεται στη Vodafone. Πριν σας πάω στο πώς, θα εξηγήσω λίγο το structure εταιρείας, γιατί θα βοηθήσει συνέχεια. Και θα σας δείξω λίγο χαλιά την αρχιτεκτονική. Η εταιρεία χωρίζεται σε δύο, ας πούμε, sections, όπως τα λέμε εμείς. Ένα είναι το digital engineering, όσο αφορά το IT, έτσι. Και ένα είναι το core IT, δηλαδή στην ουσία η διαφορά είναι το digital είναι κοντά στον πελάτη, οπότε είναι στα κανάλια μας, το MVA, το web και θα σας εξηγήσω ένα-ένα. Και το core IT έχει τα πιο hardcore συστήματα, δηλαδή μπορεί να έχει το SAP, μπορεί να έχει το CRM, το ERP και άλλα, εντάξει, τώρα μην πούμε σε διαδικασία να εξηγήσω άλλα πιο specific πράγματα. Οπότε είμαστε χωρισμένοι σε αυτούς τους δύο κλάδους και υπάρχουν solution architect και στις δύο πλευρές. Όσον αφορά το digital που είμαστε εμείς, όπως βλέπετε έχουμε 11 ομάδες, έχουμε περίπου 100 dev και QAs και 16 solution architects. Η κάθε ομάδα αποτελείται από ένα ή δύο solution architects και αντίστοιχα τους άλλους ρόλους, έτσι. Νομίζω ότι το κάνουμε σε 250 με δύο clusters αυτή τη στιγμή, APIs, και έχουμε κοντά στα 110 APIs exposed internet. Μπορείτε να καταλάβετε το complexity και πώς όλοι αυτοί οι ρόλοι και όλες αυτές οι ομάδες πρέπει να συνυπάρξουν μεταξύ τους. Γιατί αν δεν υπάρχει κάποιο governance, θα γίνει ένα χάος. Λίγο high level ηλεκτρονική όσο μπορώ να την πω. Είναι τα κανάλια, είναι τα apps που έχουμε, το CQ, το Handlers App που είναι στον δρόμο οι άνθρωποι, το web, το chat που χρησιμοποιείτε κάποιοι από εσάς ίσως. Είναι μια e-commerce πλατφόρμα που έχουμε τώρα που είναι καινούργια που πουλάμε πράγματα στο site όπως τηλεοράσεις. Έχουμε μια πλατφόρμα πάλι που γίνεται για τα καταστήματα, οπότε όταν πάτε σε ένα κατάστημα χτίζουμε ένα καινούργιο software που θα μπορεί ο agent να χρησιμοποιεί. Και όλα αυτά επικοινωνούν με APIs. Οπότε έχουμε ένα layer που το ονομάζουμε Digital Experience Layer, ή DXL στους φωταθωναίους, που είναι όλα τα microservices που σας είπα πριν. Δηλαδή, έχουμε ένα layer που έχουμε όλα τα microservices, εκτός από την e-commerce που είναι ένα ξεχωριστό cluster που πάλι έχει microservices. Όμως, οπότε επικοινωνούν μεταξύ τους. Και όλα αυτά πρέπει να μιλούν με τα core συστήματα. Τα core συστήματα επικοινωνούν θα γίνεται μέσω ένα service bus, οπότε έχουμε software επικοινωνία. Είτε θα γίνεται με το νέο layer που έχει γίνει στη Vodafone, το Shell, που είναι componentized layer. Άμα θέλετε να δείτε περισσότερο γι' αυτό, έχουμε και στο tech blog. Υπάρχει μια ομιλία από τον Devox από τα παιδιά, να μπείτε να δείτε πιο μέσα τι είναι και πώς γίνεται. Που είναι με microservices και αυτό, οπότε είναι πιο καινούριο. Και πίσω να τα PSS συστήματα, δηλαδή τα συστήματα που έχει επαγγελία, πώς θα πάρετε ίντερνετ στο κινητό, πώς θα πάρετε fixed line στο σπίτι. Είναι κάποια hardcore συστήματα που είναι λίγο πιο παλιά, αλλά γίνεται μια τεράστια προσπάθεια που ξεκινάει αυτή τη στιγμή να γίνουν όλα modernize και να γίνουν όλα αυτά με microservices. Το αναφέρθηκε λίγο πριν, η Vodafone globally έχει αποφασίσει να ακολουθήσει το TMF Forum. Το TMF τι είναι στην ουσία, είναι ένα consortium που έχουν κάνει κάποιοι leaders στην αγορά και αποφασίσαν να κάνουν ένα open ecosystem, ώστε να έχουμε κάποια standards. Οι βασικοί πυλώνες που είναι το open, αυτά είναι όλα open source, μπορείτε να πείτε να δείτε στο site, δεν θα επαθύνω πολύ. Είναι Open Digital Architecture, έχουν φτιάξει το λεγόμενο ODA, που στηρίζει τους 4 βασικούς πυλώνες, το business, το information systems, το deployment και το implementation. Και προφανώς όλα αυτά έχουν governance. Το business, στην ουσία, εμείς με αυτό που ασχολούμαστε είναι το business capability που λέμε εδώ στο Vodafone. Οπότε μας ενδιαφέρει αυτά που δίνουν στους πελάτες να τα προσπαθήσουμε να τα ομαδοποιήσουμε με ένα business capability. Για παράδειγμα, άμα ένας πελάτης πρέπει να κάνει onboard, μπορεί να έχει 50 business capabilities επάνω. Εντάξει, τυχαίο το νούμερο, απλά θέλω να πω δεν είναι ένα πράγμα. Το σπάμε σε κομμάτια και χρησιμοποιούμε πολύ ένα process framework που έχουμε, το ITOM, ώστε να υπάρχει μια common γλώσσα μεταξύ των τμήματων, όχι μόνο το IT, αλλά και του παρεμφερεί ανθρώπων που δουλεύουν με το IT για να καταλάβουν. Και το πιο σημαντικό είναι το information framework, δηλαδή το TMF τι έχει κάνει. Σκεφτείτε ότι όπως ένας developer λες πάρε φτιάξει ένα API, θα φτιάξει ένα σχήμα. Οπότε αυτοί έχουν φτιάξει συγκεκριμένα σχήμα, οπότε υπάρχει ολόκληρο data modeling από πίσω, το οποίο το ονομάζουν C, information είναι εδώ στη φωτογραφία. Οπότε όλα τα APIs που έχουν από κάτω που βλέπετε σαν κατάλογο βασίζονται πάνω σε αυτό το data schema, ας πούμε. Το οποίο είναι fixed, αλλά έχουμε κάνει και αλλαγές πολλές και εσωτερικά και εξωτερικά. Οπότε αυτοί είναι οι 3 πυλώνες. Και η Vodafone γενικά σαν group και της Ελλάδος έχουν αποφασίσει ότι όσο περισσότερο APIs χρησιμοποιούμε θα πρέπει να είναι από αυτό το κατάλογο. Προφανώς έχουμε και custom πράγματα, αλλά προσπαθούμε δηλαδή να είμαστε πάνω σε αυτό το framework, ας πούμε. No political affiliation. Η Vodafone εδώ είναι API first. Τι σημαίνει αυτό? Ότι ο solution architect της κάθε ομάδος πρέπει πρώτα να κάνει το end-to-end design, να αποφασίσει τα APIs, πώς θα είναι, πώς θα διαχειριστούμε, και αφού τελειώσει τη δουλειά του, κάνοντας το high-level design που λέμε εμείς εδώ εσωτερικά, θα πρέπει να το δώσει στο developer για να το κάνει implement. Οπότε είμαστε API first. Τι σημαίνει τώρα αυτό? Σκεφτείτε ότι από τις ομάδες που σας έδειξα πριν, στην ουσία ήταν 11. Εδώ έχω πάρει ένα παράδειγμα που οι δύο χρησιμοποιούν το λεγόμενο TMF637. Τα νούμερα τα έχουν πάρει καλύτερα από το τηλέφωνο της γυναίκας, που να ξέρετε. Που, για παράδειγμα, οι δύο χρησιμοποιούν standard API, το σχήμα, τα list, αλλά έχουν το πιο σημαντικό πεδίο στο Vodafone είναι το κινητό. Ο ένας το έχει βάλει στο product.name, ο άλλος το έχει βάλει στο product.id. Και μια τρίτη ομάδα, τυχαία, έχει τελείως διαφορετικό σχήμα. Σκεφτείτε τώρα, 3 SA, πόσοι developers, πόσοι QA, ο καθένας θα κάνει το δικά του. Θα γίνει χάος. Όχι μόνο αυτό, δηλαδή σκεφτείτε deployment, ο καθένας πρέπει να κάνει το δικό του. Ο QA, άμα πει θέλω να αλλάξει ομάδα ή ότι θέλω να πάω να δω κάτι άλλο, θα πρέπει να τα μάθει την αρχή. Οπότε δεν είναι πολύ καλό να έχουμε τόσο app scroll που λέγεται και ο καθένας να κάνει ό,τι θέλει και γι' αυτό προσπαθούμε να το κάνουμε όσο πιο governed γίνεται. Οπότε προσπαθούμε να κάνουμε standardized API που χρησιμοποιούμε at least. Που τι σημαίνει αυτό? Παίρνουμε τον κατάλογο, εδώ έχω δώσει ένα καλό παράδειγμα, έχει και άλλα πάνω, απλά εντάξει δεν μπορούσα να τα βάλω όλα. Τα footer τα χωρίζουμε σε κατηγορίες, όπως θα μπορείτε να δείτε, product, service, customer. Και προσπαθούμε δηλαδή στις λύσεις που έρχονται να χρησιμοποιήσουμε όσο πιο πολύ TMF Open APIs μπορούμε. Νομίζω τώρα είμαστε 70-30, δηλαδή 70% είναι standardized, 30% είναι custom, γιατί προφανώς δεν υπάρχει κάτι και θα θέλει πολύ χρόνο να το φτιάξουμε. Οπότε, γιατί το business προχωράει, πρέπει και εμείς να βγάλουμε κάτι στην παραγωγή. Και κάτι πολύ σημαντικό που δίνει είναι για παράδειγμα η e-commerce πλατφόρμα που έχουμε, έχει ας πούμε τα δικά της APIs. Ας πούμε έχει ένα set από 50 APIs, τα οποία είναι με το δικό τους data model. Εμείς όμως, επειδή έχουμε TMF, θα πρέπει να κάνουμε wrappers για να μιλήσουν αυτά τα δύο μεταξύ τους, γιατί το καθένα έχει το δικό του σχήμα. Οπότε τι έχει κάνει η Global στην Vodafone, πήγε στην εταιρεία που έχει το e-commerce και λέει: κοίταξε να δεις, εγώ θα το βάλω σε 10 χώρες. Απλά θέλω από το προϊόν αυτό καθεαυτό να έχει TMF APIs. Οπότε έχουν αρχίσει και βάζουν μέσα στο προϊόν, οπότε να υπάρχει standardization και με τους partners, για να είναι πολύ πιο εύκολο το integration που χρησιμοποιούμε. Αυτό όμως δεν φτάνει. Γιατί αν εγώ χρησιμοποιήσω, για παράδειγμα, το product inventory που είναι το που φέρνει τα asset πελάτη, asset εννοούμε τα κινητά μας και τις speech γραμμές, ο καθένας μας μπορεί να το έχει κάνει το σχήμα διαφορετικό interpretation. Εγώ μπορεί να έχω βάλει το πεδίο στο product.id, ο Ρουμάνος να το έχει βάλει σε κάτι άλλο. Αλλά και οι δύο χρησιμοποιούμε έξτρα λεφτά. Οπότε έχουμε αρχίσει εσωτερικά να κάνουμε με άλλες χώρες ένα harmonization, κυρίως με τις χώρες που βλέπουμε εδώ, Ιρλανδία, Πορτογαλία, Τσεχία και Γερμανία, ώστε όχι μόνο να έχουμε standard APIs, αλλά να είναι και harmonized. Δηλαδή να καταλαβαίνουμε την ίδια γλώσσα, ότι το νούμερο θα βάλω εκεί. Αυτό απαιτεί και πολύ βοήθεια το business, γιατί αν δεν έχουμε business harmonization, ό,τι και να παλέψουμε εμείς από το IT θα είναι λίγο δύσκολο να το πετύχουμε. Οπότε γίνονται προσπάθειες εσωτερικά και με άλλες χώρες να το πάμε ένα level παραπάνω και να αποκτήσουμε ένα harmonization, ώστε να έχουμε reusability όχι μόνο μεταξύ Ελλάδας, αλλά και μεταξύ χωρών της Vodafone. Θα το πάω λίγο στο πιο πρακτικό. Γενικά έχουμε χτίσει κάποιους κανόνες σαν solution architects. Χρησιμοποιούμε πολύ documentation. Κάποιους αρέσει, κάποιους τους αρέσει. Προσπαθούμε να έχουμε template at least, δηλαδή να έχουμε specific κομμάτι. Ας πούμε, κάνουμε ένα high level design, το οποίο θα έχει όλα τα integration points με όλα τα συστήματα που χρειάζονται για το συγκεκριμένο flow. Έχει swagger, θα πρέπει να δούμε ποια API θα χρησιμοποιήσουμε, τι μεθόδους security θα έχει. Τα API που θα χρησιμοποιήσουμε θα πρέπει να έχουν σωστό naming, να έχουμε versioning, πώς θα κάνουμε querying, πώς θα κάνουμε filtering. Δηλαδή όλα αυτά προσπαθούμε να δημιουργήσουμε κανόνες. Προσπαθώ να κάνουμε evaluate, γιατί μπορεί κάποια να είναι overwork, οπότε να πούμε παιδιά αυτό δεν χρειάζεται, να λείπει κάτι και αντιστοίχως να το προσπαθούμε να το βάλουμε. Και γενικά έχουμε ένα API Management Platform που βοηθάει πολύ το developer experience, γιατί μπορεί ο καθένας να πει και να δει τι είναι exposed, τι μέθοδο security έχει, πώς θα το καλέσει, να πάρει παράδειγμα, να το κάνει try, να βάλει νέα channels πάνω, δηλαδή είναι πολύ εύκολο. Το οποίο βοηθάει και πολύ στο monitoring, στο analytics, ώστε να δούμε ποια είναι περισσότερο traffic, τι πρέπει να δώσουμε περισσότερη σημασία γιατί είναι πιο σημαντικό. Και προσπαθούμε δηλαδή να χρησιμοποιούμε πάνω κάτω τα ίδια για να έχουμε usability, γιατί όπως σας είπα δεν είναι μόνο το cost development, είναι και το cost deployment, είναι το effort που πρέπει να δώσουμε, οπότε προσπαθούμε πολύ να τα έχουμε govern και να το πετύχουμε αυτό. Για να πάρω ένα παράδειγμα, αν έρθει ένα business requirement ότι ο agent στο κατάστημα θέλει να κάνει search ένα customer. Πάω εγώ και λέω είμαι ο τάδε, θέλω αυτό. Πρώτα πρέπει να με βρει ο agent, οπότε ο SA ο αντίστοιχος θα πρέπει να σκεφτεί πώς θα γίνει η λύση. Και πήρα ένα παράδειγμα του customer search που με βάση τα standardized API πρέπει να χτυπήσει 3 και όχι 1. Γιατί τι σου λέει το TMF, λέει τον individual τον παίρνεις από αυτό. Το product θα το πάρεις από κάποιο άλλο και το billing account κάπου αλλού. Οπότε αναγκαστικά εμείς για να μην βάζουμε πολύ logic μπροστά στα κανάλια στα front-end, χτίζουμε κάποια aggregation API, όπως είναι το customer search, για να κάνουμε τη λογική. Και σκεφτείτε τώρα, δηλαδή, στο παράδειγμα πριν, ότι αν θέλω εγώ μια αλλαγή, από το να έχω 11 customer search, έχω ένα. Οπότε με ένα deployment, όλα τα κανάλια μου αυτόματα έχουν πάρει την αλλαγή. Και γλιτώνουμε πάρα πολλά πράγματα με αυτό. Και επίσης βοηθάει και στο να κάνουμε, γιατί άμα κάνω εγώ customer search με το billing account μου, που είναι για το λογαριασμό μου, για να χτυπήσω τον individual πρέπει να έχω ένα φοινί, για παράδειγμα. Οπότε στην ουσία αυτό το business logic και το πώς θα είναι η ροή, το κάνει το aggregation API που χρησιμοποιούμε για να κάνει cater αυτές τις περιπτώσεις. Στην ουσία, ποια είναι η διαδικασία, όπως σας είπα, ο SA ξεκινάει, κάνει το design με τα templates, με τα roles που έχουμε θέσει. Και μετά έχουμε ένα process το οποίο κάνουμε μέσω Jira. Οπότε κάνει create το ticket, ότι έχω κάνει το HLD. Υπάρχει solution architect που κάνει δηλαδή την αρχιτεκτονική. Μετά υπάρχει ένα review team που είναι λίγο πιο senior ανθρώπους μέσα στην εταιρεία που έχουν κάποια χρόνια, που παίρνουν αυτό το ticket και πρέπει να το κάνουν review. Review με βάση κάποια guidelines πάλι που έχουμε, δηλαδή έχει βάλει authentication το σωστό, μήπως έχει ξεχάσει κανένα και έχουμε gap, με τα data τι παίζει. Έχει σκεφτεί το σενάριο security, API ποια χρησιμοποίησε. έχει πάρει το σωστά API ή έχει κάνει κάτω και πρέπει να βρούμε άλλα. Οπότε υπάρχει μια λούπα εδώ, που αν ο reviewer βρει προβλήματα, ξαναγυρνάει πίσω στον architect, μέχρι να καταλήξουν στο τι είναι OK και να το πάρει ο developer να κάνει. Επίσης, την ευχέρεια τώρα εδώ του reviewer, επειδή νομίζω όλοι ξέρουμε από technical debt εδώ, είναι το αν θα προχωρήσει κάτι ή όχι. Δηλαδή, προφανώς το business case να βγει κάτι χθες, αλλά και εμείς σαν IT θα πρέπει να κάνουμε safeguard κάποια πράγματα. Εντάξει, προφανώς δεν μπορούμε να το κάνουμε πάντα, αλλά κάποιες στιγμές μπορούμε να πούμε: κοίταξε, αυτό εδώ είναι μεγάλο gap, δεν μπορεί να βγει το έργο, πρέπει να το φτιάξουμε πρώτα και μετά θα συνεχίσει, οπότε θα πρέπει να πάει λίγο παραπίσω. Τώρα γιατί το κάνουμε. Γενικά, άμα δείτε εδώ μια έρευνα, αυτά είναι τα top challenge που βλέπουν οι εταιρείες. Το scroll είναι αυτό που σας είπα στην αρχή, ότι ο καθένας μπορεί να κάνει τα δικά του σε 11 ομάδες, αν δεν βρες μετά τι φταίει και τι δεν φταίει. Ένα πολύ δύσκολο task είναι το maintaining an accurate inventory. Επειδή γίνονται τόσες αλλαγές καθημερινά, είναι λίγο δύσκολο και προσπαθούμε κι εμείς, δηλαδή δεν είναι κάτι που δεν το έχουμε πετύχει 100%, να υπάρχει ένα σωστό inventory από τα APIs που χρησιμοποιούμε. Δηλαδή, σκεφτείτε από τα 250, κάποια μπορεί να μην τα ξέρουν. That's reality. Και το σημαντικό μετά είναι να δεις αυτό που είπαμε, το monitoring, το traffic. Γιατί μπορείς να δεις ποιο είναι πιο risky, δηλαδή, άμα είναι payment, θέλει περισσότερη προσοχή, δεν μπορείς να το αφήσεις χωρίς να το κοιτάς. Ή τα top APIs, με τα authentication APIs, ή αυτά που φέρνουν τα customer info, έχουν τρελό traffic. Μπορεί να έχουμε και 800.000 requests την ημέρα, 1 εκατομμύριο. Οπότε πρέπει να είμαστε on top, να τα μονιτοράρουμε, να βλέπουμε τι γίνεται, ποια κανάλι το καλεί, αν πρέπει να κάνουμε scale, αν δεν πρέπει να κάνουμε scale. Οπότε είναι πολύ σημαντικό να υπάρχει όλη αυτή η έννοια του governance. Και πιο συγκεκριμένα, τα προβλήματά μας εστιάζουν στο documentation. Έχουμε πολλά design documents, γιατί τα features είναι πολλά, οπότε παράγουμε συνέχεια documents. Και είμαστε στη διαδικασία να δημιουργούμε master documents, οπότε να πειράζουμε μόνο το master και τα άλλα απλά να είναι για το process που σας έδειξα πριν. Να υπάρχει integration και locally και με άλλες χώρες, δηλαδή να μην σκεφτόμαστε μόνο OK, το έβγαλα το έργο τέλος, κοιτάμε πάρα πολύ το reusability πλέον. Οπότε να σκεφτούμε λίγο και πιο globally. Deprecation, εντάξει, είναι ένας πόνος νομίζω, ότι υπάρχουν παλιοί clients που δεν γίνονται ποτέ decommission. Οπότε μπορεί να έχεις 3 versions από το ίδιο API στην παραγωγή και να πρέπει να το κάνεις handle και τα εταιρεία. Δηλαδή, βγάζεις κάτι καινούργιο και ποτέ δεν βγάζουμε το παλιό. Όχι ποτέ, απλά ενώ υπάρχουν παλιοί clients στα κινητά, γιατί αν έχει πάρει όλο το version το application το 4 και έχουμε φτάσει στο 11, αν δεν σταματήσει να δουλεύει το 4, εμείς αναγκαστικά πρέπει να έχουμε 3 versions στην παραγωγή. API Catalog είναι ένα μεγάλο θέμα. Έχουμε κάνει κάποιες κινήσεις να το φτιάξουμε. Αλλά προφανώς επειδή τα features είναι πολλά, πόσο documentation να γράψει ο sales, δηλαδή, ενώ πρέπει και να κάνουμε και κάποια πράγματα να τα βγάλουμε στην παραγωγή. Και το deck που είπαμε ότι πρέπει να σκεφτόμαστε κάπου στη μέση των πτέρων και κάπου στην ταχύτητα. Οπότε προσπαθούμε λίγο σαν IT να κάνουμε safeguard κάποια πράγματα. Αυτό είναι το μεγαλύτερο challenge των sales στη Vodafone, να ξέρετε. Γιατί όπως σας είπα πριν, το TMF έχει ένα σχήμα, αλλά δεν μας καλύπτει πάντα. Οπότε τι κάνουμε, υπάρχει εσωτερικά ένα αστείο που λέμε πάμε στους σοφούς. Υπάρχει ένα API Guild το οποίο πρέπει να κάνεις challenge ότι παιδιά εδώ θέλω ένα καινούριο object γιατί αυτό που είναι δεν μου αρκεί. Και πρέπει δηλαδή να περάσουμε ένα process σε ένα TMF API το οποίο μπορεί να γίνει στη Vodafone και μπορεί η Vodafone να το κάνει και στο TMF forum. Και το δεύτερο είναι το documentation. Εντάξει, καλό το documentation, αλλά τέλειο δεν μπορεί να γίνει ποτέ. Γιατί δεν έχουμε τον χρόνο να κάνουμε τέλειο και ούτε πρέπει να γίνει τέλειο. Οπότε, μάλλον ο δράκος είναι πιο λογικός από το να έχουμε ένα τέλειο API documentation. Γενικά, αυτά που κοιτάμε, αυτό τώρα που σας έχω βάλει εδώ είναι ό,τι είναι API related, όχι solution architecture. Κοιτάμε να κάνουμε contract testing, γιατί τα παιδιά στην ομάδα έχουν κάνει κάποια conformance testing και στο forum. Conformance σημαίνει ότι έκανε το design, ο developer όμως μπορεί να κάνει τα δικά του. Γιατί θα βγει πιο γρήγορα. Οπότε αρχίζουμε να κάνουμε conformance testing ότι όντως όπως είναι το Swagger, όντως είναι υλοποίηση. Και κοιτάμε τώρα να δούμε πώς μπορούμε να το βάλουμε και στο CI/CD να γίνεται αυτόματο. Εντάξει, προφανώς όχι να σταματήσουμε το deployment, αλλά τουλάχιστον να σηκώσουμε ένα flag ότι κάτι πρέπει να φτιάξουμε. Architecture Decision Records, επειδή η ομάδα μεγαλώνει συνήθως έρχονται καινούργια παιδιά, σου λέει: Ωπα, αυτό γιατί το είχαμε κάνει έτσι. Έλα, δεν θυμάμαι εγώ γιατί το είχα κάνει έτσι. Οπότε προσπαθούμε να φτιάξουμε ένα κατάλογο από αποφάσεις, τουλάχιστον σημαντικές που είχαμε πάρει, ώστε οι κοινές συνάδελφοι και από άλλα τμήματα να καταλαβαίνουν γιατί το κάναμε τότε. Error codes, ένα μεγάλο πράγμα. Προσπαθούμε να έχουμε conformity και στα error codes, όχι μόνο στα HTTP, αλλά και στα business error codes. Δηλαδή, έχουμε αρχίσει να στείλουμε ένα κατάλογο. Αυτό θα βοηθήσει πολύ και στο QA και στο call center, ας πούμε, άμα το παίρνει τηλέφωνο πελάτης και πει βλέπω Α144. Θα σου πει το call center, τι είναι αυτό, παιδιά. Ενώ άμα το φτιάξουμε και έχει εκείνη την ώρα μπροστά, θα μπορεί κατευθείαν να πει στον πελάτη: ναι, έχετε ένα πρόβλημα με την ταυτότητά σας, πρέπει να κάνετε επαλήθευση στη για παράδειγμα. Οπότε θα βοηθήσει και το customer experience. Swagger tooling, εντάξει, γράφουμε όχι τόσο πολλούς swaggers, αλλά από ό,τι φαίνεται, επειδή προσπαθούμε να κάνουμε και automation, API deployment με βάση τα swaggers τώρα στο μέλλον, θα πρέπει για να γράφουμε swagger να έχουμε κάποιο εργαλείο, οπότε κοιτάμε λίγο στην αγορά σαν POC αν μπορούμε να χρησιμοποιήσουμε κάτι. Να κάνουμε καλύτερο το API catalog που έχουμε και να το κρατάμε ενήμερο. Care collections, όλη η εταιρεία ζητάει care. Άμα δείτε τα chat στο Teams, δώσουμε ένα care γι' αυτό, είναι χαμός. Οπότε προσπαθούμε να το κάνουμε κάπως σαν ένα master σύστημα. Κάποιοι να τα πειράζουν και όλοι να τα παίρνουν. Θα βοηθήσει πολύ την καθημερινότητά μας. Και Gen.AI προφανώς, το hot topic of the year. Προσπαθούμε να δούμε πώς μπορεί το Gen.AI να μας βοηθήσει στην καθημερινότητα, δηλαδή να μας γράψει πιο γρήγορα ένα sequence diagram. Να δει τι APIs έχω, να μην ψάχνω στο κόφινο 50 σελίδες, να μου το πει κατευθείαν. Προσπαθούμε να δούμε με POCs πώς μπορεί αυτό το πράγμα να μας βοηθήσει. Νομίζω πάνω κάτω αυτά είχα να πω. Thank you. Αν έχετε ερωτήσεις.
Καταρχάς, ευχαριστούμε για την παρουσίαση, ήταν πάρα πολύ αναλυτικό και ωραία. Είναι κάτι που είναι κάπως ανακληρά ακόμα. Είπες πριν υπάρχει το cost του development και το cost να βγει κάτι στο production. Το κόστος του retention ποιο είναι? Δηλαδή, υπάρχει μέσα στο management κάποιος ο οποίος, το governance που είπες, ο οποίος βλέπει, επειδή υπάρχουν πάρα πολλοί APIs, κάποιος βλέπει κατά πόσο ένα API που είχε βγει πριν από 15 χρόνια πλέον χρησιμοποιείται, το κόβουμε, ας πούμε, άμα φτάσει στο 30%.
Κοίτα, γενικά τρέχουμε ασκήσεις reporting, δηλαδή έχουμε φτιάξει dashboards σε διάφορα εργαλεία, τα δεν μπορώ ποια είναι, που κοιτάμε traffic, ας πούμε. Άμα δούμε ότι ένα το προηγούμενο χρόνο ήταν πάνω και έχει πέσει 50-60%, ίσως πρέπει να πάρουμε action. Ή άμα δούμε ότι έχει 5 call τη εβδομάδα, μήπως πρέπει να το κάνουμε deprecate. Θέλω να πω, γίνεται περιοδικά αυτό, είναι ότι είμαστε στον top. Τρέχουν ασκήσεις μέσα στον χρόνο, μπορώ να σου πω.
Και υπάρχει ανάγκη για τόσο πολύ μεγάλη εξειδίκευση.
Εξειδίκευση, τι εννοείς?
250 APIs, υποθέτω πηγαίνουμε ανάλογα με το customer, με το segment.
Ναι, είναι λίγο scattered. Τη μέση είναι αλήθεια, θα πω, δεν θα πω εισαγωγικό. Προσπαθούμε και λίγο να το μαζέψουμε, γιατί είναι πάρα πολλά.
Κύριε, ευχαριστώ πολύ.
Κάποιος άλλος?
Να κάνω κι εγώ μια ερώτηση. Ποιο είναι το μεγαλύτερο challenge όταν προσπαθείς να κάνεις...
Τα ξέρεις, είναι διαβασμένος.
Το μεγαλύτερο challenge ποιο είναι?
Το μεγαλύτερο challenge. Νομίζω το να κάνεις keep track. Δηλαδή, ας πούμε και εμείς που ασχολούμαστε, μπορεί κάποιος να είναι 5 χρόνια στην εταιρεία, να έχει χρησιμοποιήσει τα 50, δηλαδή 50, δεν τα ξέρουν όλοι όλα. Δηλαδή, πρέπει να μιλήσουμε με έναν άνθρωπο. Γιατί ο καθένας στην ομάδα του έχει το δικό του business oriented κομμάτι, ας πούμε, έτσι. Οπότε πρέπει να μιλήσουμε με κάποιον. Οπότε μες στη μέρα θα πρέπει να πάω να μιλήσω με αυτόν. Αυτός θα ξέρει γιατί έχει ασχοληθεί με τα payments. Να πάω σε αυτόν γιατί έχει ασχοληθεί με το prepay. Αυτός ξέρει το fix καλύτερα. Οπότε δεν υπάρχει συνολική εικόνα κάπου.
Οπότε το collaboration, ας πούμε.
Δεν είναι ότι δεν το κάνουμε. Το κάνουμε, απλά θα σου τρώει πολύ χρόνο. Αυτό είναι το. Γι' αυτό προσπαθούμε να κάνουμε αυτά τα master pages, ώστε κάποιος να πάει κατευθείαν και να πει το διάλογο το βρήκα. Οκ, θα μιλήσω, αλλά ξέρεις, δεν είναι ότι θα φάω τόσο χρόνο.
Αυτό ίσως είναι και κάτι που το Gen.AI μπορεί να βοηθήσει. Δηλαδή, άμα έχεις μια βάση γνώσης και θες να κάνεις μια ερώτηση.
Ναι, προσπάθω.
Ειδικά και σε κάποια προϊόντα που μπορεί να φτιάξει, που γράφεις όλο το documentation, έχουν αρχίσει και το παρέχουν σαν feature. Να κάνει μια ερώτηση και να απαντήσει από όλο το documentation.
Θα βοηθήσει πάρα πολύ το συγκεκριμένο μάτι.
Καλησπέρα. Γιατί το governance αγγίζει και τα aggregate APIs, ενώ είναι public, ας πούμε, και δεν πρόκειται να το καλέσει κάποιος, ας πούμε, στο
Κοιτάξτε, σε πιο πολύ κομμάτι μας νοιάζει να το χρησιμοποιούμε. Δηλαδή, δεν θέλουμε να κάνει πρόσκληση να πάει λογική στο χρόνο. Γιατί μετά είναι πολύ το deployment. Σκέψου ότι έχεις ένα application mobile, άσο web. Πώς θα γίνει, εσύ για να πάρεις update πρέπει να κάνεις update από το Play Store. Ενώ άμα το έχεις πίσω, το παίρνεις κατευθείαν. Δεν χρειάζεται δηλαδή, να κάνεις κάτι.
Ναι, η λογική είναι ξεκάθαρη. Απλά προσπαθώ να καταλάβω αν οι αυστηροί κανόνες εισαγωγικά επιταχύνουν τη διαδικασία ή την κάνουν πιο.
Εξαρτάται την περίπτωση, θα πω. Αλλά εντάξει, δεν είναι ότι ξέρεις, άμα το κάνεις έτσι δεν βγαίνει. Είμαστε λίγο. Προσπαθούμε και εμείς να βοηθήσουμε το business, δεν προσπαθούμε να το κόψουμε.
Κάποια άλλη ερώτηση?
Τέλεια.
Ευχαριστώ. Ευχαριστούμε τον Δημήτρη. Τώρα για την επόμενη ομιλία θα αλλάξουμε λίγο επίπεδο, θα μιλήσουμε για κάτι πολύ πιο low level. Και ο Juan Κρουζιώτη θα μας μιλήσει για το πώς να φτιάχνουμε εξαιρετικά performant APIs.
In English, so sorry for my lack of Greek. But let me see, how do I expand this on Windows? How do I make it big?
Δημήτρη.
Full Christian.
Ναι.
How many of you use Node, by the way, to create APIs? Okay, fair amount. It's gonna be fun. Yeah, there you go. Cool. So on this talk, we're gonna be covering how could we create APIs that are massively faster than alternatives at Node.js. I'm not only picking on Node.js, we're going to be also touching on other programming languages, but it's mostly just an example as a very popular technology. But the idea is how can you create APIs that are so efficient that you can either host them for a fraction of the price that you would be used to hosting them, or for the same price maybe that you're paying right now for your Node.js APIs, you can serve also a bigger amount of clients, right, for the same price. So who I am, why you should be listening to me, I guess. I'm a technical steering committee member of JSON Schema. I'm also an O'Reilly book author. You can see the book in there and read it if you're curious. I also have my own company. I'm doing consultancy. I was also doing contracting at Postman, so that's how we met. So I was leading an R&D team at Postman for a couple of years. I've done a lot of research at the University of Oxford, and some of the stuff that you're going to be seeing comes out from a lot of that research, so you're going to see some of that. I'm mainly a C++ developer. I come from a background that is very performance-oriented. I've been doing not only APIs, but IoT and embedded development, so that's where I'm trying to connect the dots and draw all the lessons that I've learned in these environments and try to apply them on APIs. You have my website in there. I have a lot of stuff. If you want to connect later on, I will be more than happy. So, why APIs? We all know that APIs are very popular, otherwise it probably wouldn't be here. But just to give you some cool numbers, APIs outpace other internet traffic, comprising 57% of dynamic internet traffic as processed by Cloudflare. That's a recent metric on a report of 2024. And actually, most APIs run on Node. So if we take a look at the State of APIs Rapid API report, they have a 2022 one. They actually haven't done a latest one for some reason. You can see in the chart, JavaScript is ranking very high. And even within JavaScript, I mean, we know there are many runtimes that we can use to develop APIs. If we try to quantify them in some way, I mean, and one lossy way of trying to do so is this website called Stackshare.io. It gives you statistics about who uses what technologies. Again, not a perfect metric, but good enough probably. It's already showing Node to be way more popular than Bun and Dino, right? So I think from that we can correlate that most APIs are probably based in Node. So that's why I'm heavily picking on Node today. So yeah, question: are you running Node.js too? I think a lot of people raise their hands. So sounds like you will enjoy it. So we know that APIs are eating the world, and at the same time, cloud providers like AWS are kind of eating us. its cloud computing cost is very high. You probably are aware of that. If you work at any company doing APIs and you have some level of exposure on the API cloud bills, they tend to be very, very scary. And I have this report, which is quite interesting, saying that most enterprises, they spend more than $1 million a year on cloud computing from the respondents on this particular report. They started in bigger companies. And so that's kind of the status quo at the moment. We're like throwing so much money at AWS. Can we actually do better? I believe that we can. That's going to be the main thing that we're going to be looking into. So also our planet is very sad. We consume a lot of electricity for running the systems that power everything that we're actually using on a daily basis. This paper, it got very popular on LinkedIn or Hacker News. You might have seen it. It was like a month ago or something like that. But they were trying to measure energy space efficiency across a lot of popular programming languages. So you can see JavaScript over there. They are, for example, doing a lot of analysis on different cases. In this case, they implemented a binary tree. A binary tree implementation on JavaScript, it's like 8x less energy efficient than a C1, right? Just to give you a number. Also, for comparison, for example, a Python one is 45x more electricity than a Node one, right? So things don't look great. And why Python? If you recall the chart that we've shown in the previous slide, Python is also the second most popular language for doing APIs. Are you guys using Python for APIs? Anybody? Okay, less than Node for sure. So I think this reflects reality somehow. So the fact is that we're wasting so much energy for doing the same things that in theory we see that we could do them a lot better, right? So how can we take advantage of that? And if you think this is not a problem, I think we're all aware of the global energy crisis that we're going on at the moment, and things like AI are only going to make this worse. The amount of electricity that we're using is just huge, and it's only going to make this problem even worse. Predictions are that the energy crisis is, at some point, start going to impact the compute that companies are trying to do, and they're going to be forced to start taking this more seriously because of the cost will rise because of electricity. And also, fun comparison, I asked Claude, very ironic, right? We're burning electricity asking AI about costs. The Apollo guidance computer, that's the computer that took us to the moon. That's the RAM and processing speed that it had. And if we compare that with a typical modern server running Node.js, so we can kind of correlate that APIs are like 50,000, 100,000 faster than the Apollo guidance computer that took us to the moon. And that, doesn't map out. We're clearly doing something wrong, or at least we could do something better. So the question is again, why are we blowing so much money and energy for doing something that we know in theory that it could be done better? So now we're going to dig a lot into how do you actually do it. Again, as a disclaimer, I'm not telling you to go and abandon Node or abandon Python and go into crazy approaches to squeeze out all of the performance that you have. This is more, like a but for your own curiosity, and you might find it useful, but again, not every API has to be super fast and cheap. If you're a startup, you probably are more interested in getting to market and surviving than starting to optimize all of these things. And also, a caveat that doing high performance APIs is very hard. And you might also struggle to find even the talent that you need to go doing those. Also the classic, quote by Donald Knutt, perimeter optimization is the root of all evil. So we shouldn't go and optimize everything just for the sake of it, right? It has to be a reason. I'm also probably a performance addict, as you're gonna see in a lot of my content. I've been doing a lot of work on performance. I'm very much into it, don't worry, I could quit whenever I want, so we know it's not an addiction, surely. But yeah, anyway. So let's assume that we do want to squeeze every performance that we can out of APIs. Again, not that we should, but let's assume that we want to, right? Let's actually explore that line of thinking and see what it takes us and what are the things that we can do. So, step number one, the clear one, you remember that graph? We know that JavaScript is not very efficient, right? If we want to go pursue that path, okay, let's actually kill the programming languages that are slow. Let's actually use a faster one. Many alternatives, both lower level, higher level. You have Rust, very popular nowadays. A lot of people are doing APIs in Rust. You have C++, and C is a popular one, is what powers the PAN engine, if you recall. Also, I'm listing Go. So Go is not as fast as the other programming languages, but it's also quite fast. I think if you're interested in high performance APIs, I've seen Go perform very, very well. So it's an interesting, middle point. Now, as I said before, I'm mainly a C++ developer. So at least for the sake of the talk, I'm going to be adopting C++. You can go pick any other language that is fast that you like. So you might be like, okay, what the fuck? C++ APIs, that sounds crazy. It's actually not that crazy, I think, if you look into it. Going back to the same chart that we went at the beginning, there are a reasonable amount of APIs nowadays actually developed in C++. And these APIs are mostly very famous in bigger companies. So if you're like Meta, Google, a lot of companies that truly, do truly care about scalability, it's not that rare to see C++ APIs in that context. So, okay, this is how you do a hello world API using Node and Express. Probably all you guys, know about that. I think the example makes sense. We're creating an application, we're registering a route for route. On that route, we're just responding with nothing, right? 200 OK, and then we're like listening to the port. So C++ actually doesn't have to be that scary. I maintain a module that is called Hydra. It's the one that I'm using there to implement APIs using C++. So I'm running this on production, but I want to show you, just how easy and less intimidating it can be. I think a lot of people think about C++ APIs and they think, oh, it's going to be like crazy difficult, crazy verbose, and crazy low level. It doesn't really need to be that way, right? And you can go check out this library. It's open source. If we analyze it, it's kind of the same, right? I think it's pretty readable. We create a server, we register a route on method get on slash, then on the handler we set the status OK and respond end. It's not that bad, right? Then you actually run the API on port 3000. If you even look at them like side by side, this is the Node.js one and the C++ one, not that different after all. Definitely, it can be ergonomic if you want to. That's a link, by the way, to the project, in case you want to check it out and play with it. But okay, so let's take this thing that we made. Sorry, yeah. Let's take this as the benchmark. We're doing a very basic API. It doesn't do anything, but let's take this as a test subject to see how far we can go with it. So, even just by doing this, let's, for example, first think about memory. This alone already gives you an 80x reduction of memory compared to Node. On this C++ API that I just showed you, if I compile on my Mac on Apple client, that's 0.2 megabyte per instance compared to 16 megabyte per instance in Node.js. Right? I have the specs, by the way, below. All of these you can reproduce at home. I'm not going to be like doing all demos today, but feel free to reproduce. If we also take into consideration application size, and we're going to come back later on why this is important, this also gives us a 353x reduction. So this C++ API, completely statically linked, it doesn't have any dependencies on the system other than the required ones by the operating system, 232 kilobytes. Compare that to Node.js, where just the Node.js runtime is 82 megabytes, and the application alone is 3.4 megabytes with all of those big Node modules that we're putting. So, huge reduction. Idle CPU, we're also going to come back to why this is important. We already get an 18x reduction compared to Node, right? And this is also not like quite true. I think it's actually the difference is even bigger when you consider that 0.0.1 is scalable even if we do a thread pool maximizing all of the cores in the CPU on my machine. So I have a Mac, an M3 Pro Mac with 12 cores. If I run one on each of them, it still remains at 0.01, whereas for JavaScript, we're running only one instance on one thread, and we're getting 0.18 for that. So still quite a lot. If you take a look at requests per seconds, we already get, by just doing that, a 4.7x increase. I'm testing this with this tool called WRK. Maybe some of you guys know it. It's a popular CLI tool to do load balancing testing on APIs. I'm showing the exact parameters that I'm showing there. So I'm doing 12 requesting, I think that's for 12 threads, doing a concurrency of 400 requests for 30 seconds. So with that, that's how we're hitting the API. Already gives us 4.7 increase. And actually, I had to bring down the numbers a lot, because if I increase the numbers on the parameters on WRK, Node.js will actually stop responding and I would start losing requests. But I didn't want to show, I want like a more fair comparison, at least a level where both still send requests. And startup time, it also gives us a 13x reduction. So for example, if we run the binary on the API, we get 7 milliseconds on the C++ one until the port is found. So our application is going to get the socket listening on the requests. Compared to Node.js, which is 92 milliseconds, it's still not that bad, but actually this very, very, very important metric that we're going to make use and exploit later on. So 13x reduction, that's quite nice. So how do we take advantage of these numbers? All right, this is a baseline. We have already done a huge amount of improvements by just swapping the programming languages. But what could take us to the next level? So low resource, we know that we have extremely low resource usage and we have extremely fast startup. That actually, there is one interesting way of exploiting that. Anybody has a clue, I guess, on how you would exploit that to take it to the next level on APIs?
By upscaling.
Something like that, yeah. I think you're getting into an interesting point. We are scalable. How do we scale? Actually, it's unikernels. Did any of you guys heard about unikernels? So unikernels is the idea, we're running all of these APIs on Linux. That's a traditional operating system, and we're running all of our stuff. Maybe with some exceptions aside, but the vast majority of them is Linux. What if we consider Linux to be bloat? And I think that's an interesting thought, like people wouldn't think about Linux as a bloat in their APIs. But Linux is a general purpose operating system, and it's doing a lot of stuff, even more than what your API requires. So the idea of unikernels is how could we build a tailored kernel for like the Linux kernel alongside your application that only includes what your API wants. Imagine that you take the Linux kernel and you start taking apart everything from the Linux kernel that you don't use. For example, you might not need to pay for like preemption of threads. Maybe you actually don't use the file system at all, so why are we even compiling file system support? Maybe memory allocation, I don't know. You can imagine, I guess it depends on your API. So one of the cool things here is that if we compile the kernel alongside with the application, let's say that we make them one. We make the kernel and the API one. You also you completely kill the context switching between your application and the kernel. When you're writing a program, for example, on Linux, and you say, hey, Linux, please allocate 100 megabytes of RAM for me, and you do a malloc system call. Every time that you system call, you're passing the context to the kernel does what you want, and then passes back control to you. That context switching is actually very expensive, right? With a unikernel, because our application is the kernel, in a way, we avoid that. We're running on bare metal directly, without any overhead of the kernel. So this is a graph just to make it a bit more visual. And I'm comparing many different approaches of doing this, right? So on the first one, this is a virtual machine approach, right? So on a traditional virtual machine, you have the hardware, you have the virtual machine manager, that would be like KVM or something like that. You have the guest OS and the kernel, the blue one, that would be Linux. And then you have the application on top, and that's the API, right? Then, popular model, of course, almost everybody does containers nowadays, with Docker and stuff like that. That changes the picture a bit, but it's not that much. You have the hardware, you have the guest OS kernel, which is where the containers are actually running. Then you have the container runtime on top of that, and on top of that you have your application. But actually, this is what people do in practice, which is also where a lot of the bloat comes from. Because when we run, say, an EC2 instance on AWS, we're not getting a real machine, bare metal, on a server on AWS. We are combining the first two and actually getting the worst of both, because we're running all the container overhead on top of a virtual machine that has its own overhead on top of the actual machine, right? More abstractions. Whereas with the unikernel, the picture looks like this. You have the hardware, you have the virtual machine manager, so again, you can run it on KVM or something like that, and the unikernel app. And in this case, the unikernel app is our API plus the kernel, right? We have removed like 2 blocks, right, from the traditional approach. So, how do you get started with unikernels? There are many technologies for doing this. The one that I'm personally using, and I would recommend, I'm using this in production, is Unigraph. Unigraph is an open source unikernel implementation that you can use. It's part of the Linux Foundation itself. It's actually very well known within certain circles, so it really depends on who you ask, right? But they have like a complete, if you see the tagline, Unigraph is a fast, secure, and open source unikernel development kit. Very nice to use. And it's actually very clean and efficient. You remember about programming languages making a world sad because of energy consumptions. They have this thing, 70 less power consumption compared to Alpine, Linux, and Raspbian on a Raspberry Pi. We're getting 70% energy reduction already with that. So if you go and read some of the charts in Unigraph, I'm not going to go into this a lot of detail, but for example, you can go and check this out on these are from the Unigraph website, by the way, so you can read a lot more in detail. So given this, the application size of a Unigraph application, so if you take a look, can I actually point this thing here, right? It means that our application plus the operating system, we fit everything in 2 megabytes. Imagine the size of that, way lower than a Docker container. That means that, at least from a this utilization point of view, we can fit a lot more instances on a single server. And this one is also an interesting one. So what Unigraph says in here, for the both applications that they are benchmarking, Unigraph is around 30 to 80% faster than running the same application in a container, and 70 to 170% faster than the same application running on a Linux VM. Unigraph is also 10 to 60 faster than running native Linux that would be on an actual real dedicated machine. So you can see how this whole unikernel approach, it kills so much load. We don't realize about that load because we take Linux for granted, but there is actually a lot of load, and we could get rid of it. So with that, we can already get like 50% more throughput compared to Docker for 3x less memory to run more instances and get even higher throughput, right? We take advantage of those two things, just like run and squeeze a lot more. So, but here is the real benefit. This is where the magic actually happens. What we saw before, that was actually bonus, right? This is where the real savings are. So with unikernels, remember that we saw the metric that our API can execute, I don't remember, it was like 3 milliseconds, something like that, I don't remember the number right now, right? With our C++ API. What you can do, because Unigraph can cold boot in 30 milliseconds. So if you run the Unigraph operating system along with your app, it's going to boot completely and start running your application in 30 milliseconds. That would be equivalent, like I have my Mac, right? And I press the power button, and in 30 milliseconds, the whole operating system is running, right? So because it can do that, you can take advantage of it for doing something that is called scale to zero. So because powering the machine, right, like booting the operating system is so cheap, we can actually boot it on demand for every incoming request, right? So then we combine the fast boot up of unikernels with the fast boot up of our application to pretty much like turn on and off the entire machine every time like a request is coming through, right? And even the response time can be even better than in some like Linux instances, even when taking this into account. So that means that if you're using compute where you pay as you go for compute, let's say that you're using AWS and they bill you per minute that you're running on an instance, with this one, I've seen it in production doing like a 90% reduction of costs on pay-as-you-go, right? Because the moment that you don't serve a request, maybe you have like a wait time of like 100 milliseconds or something like that, the entire machine shuts off. You're not doing any compute at all. If a request comes in, you're putting it on the fly, responding to the request and shutting it off again, right? Huge cost savings. So it is something like lambdas if you think about it, right? With lambdas, the idea is that you're only spinning up a lambda on demand to some workload coming in, but actually it's a lot faster than lambdas. Unigraph itself, they have this benchmark, comparing to AWS Lambda, running, different things like Java Spring Boot, Ruby, Django, and as you can see there, even the numbers are like 119x faster, 23x faster, 33x faster than Lambda. So we're really doing lambdas better, right? In a way, which is kind of cool. So just some thought experiment, because you can actually do this with any application compiled on the unikernel. Imagine that you can run Postgres or a database as a lambda. Pretty crazy, right? Not something that anybody knows at the moment, but actually you can combine Postgres, which is a C project, along with Unicraft, develop a unikernel for it, and you have Postgres as a lambda. And we all know that databases also cost a lot of money to host, so this could, really reduce costs as well, which is kind of fun. So if we have all of that, right? Take a look, for example, at this. I don't know if you ever use Booter. Booter is a provider of machines. I'm choosing this one because it's quite cheap, right? So if you go to the pricing page, this is the cheapest instances that they have. So they are offering 1 virtual CPU, half a gigabyte of RAM. They have some generous bandwidth. They have 10 gigabytes of storage, and that costs $3.50 a month, right? Very basic, right? If you're running Linux on this one, you're not going to get a lot, right? It's maybe just for experimentation of an MVP. But the thing is that if you take into account the numbers that we have, so for example, we can put on demand and shut it off. We might only require 1 virtual CPU. With that half a gigabyte of memory, if you remember, we're consuming 2 megabytes of RAM. That means that on this tiny machine, right, we could run like through 200 instances of our application, maybe, at best. So then the numbers start looking pretty different. And you can actually even do this for free. So Unicraft, they also have their own hosting provider. They have technology to host and manage unikernels on AWS for you. So that's like a paid plan that they have as a business. They even offer this plan where you can have 2 active instances of unikernels for free. Now with 2 active instances, if we combine that with a C++ API like the one that we have made, right, and with the numbers that we get, that alone, that free plan, could get us to maybe 50K requests per second on a production API running completely for free. You know? Then we actually get a free lunch, right? Now we are eating AWS now, they're not eating us anymore. So, you know, amazing, we did it. Now what, right? It's so cool. But yeah, can we actually do more, right? I think we can actually do more. So, what do APIs actually do? There is one element in common that I've seen that APIs do always, all the time, and that's input and output validation, right? Almost all APIs are going to do that in a way, otherwise they're probably very unsafe, right? And they're just taking whatever without checking anything. You know, maybe this applies that it's actually JSON-based APIs. Gateways in particular, this is a good use case, right? Almost everybody uses gateways in some way, and they are a key element of scalability. So, again, if you're using OpenAPI, are you guys using OpenAPI? Anybody? Probably quite a lot. Well, okay, not that many, but yeah.
If you call it Swagger, perhaps.
Yeah, maybe. So OpenAPI, it defines request bodies using what? Well, using JSON schema, right? Async API goes out as well if you're using XAML, if you're using almost any API specification, you're doing validation with JSON schema in some way or another. If you're using JSON schema, you might be familiar with the HJV project. It's the most popular JavaScript validator of JSON schema available out there. They even have a Mozilla grant. At some point, they were employing people to work full-time on that. They have a lot of donors. They have a massive amount of weekly downloads. Extremely popular project, and it's actually the backbone of so many APIs. For example, I know Postman is actually using this, production servers, right, as an example. And various frameworks actually use HJV under the hood. So you might not even realize that you're using HJV when you're building an Express app, and actually you are, if you take a look at it under the hood. So it's very ubiquitous between a lot of these things. But HJV is slow, right? And that comes as a surprise. If you see the name, you know, HJV, I think is like another JavaScript like fast validator or something like that, right? We saw, for example, that if you're using HJV to validate requests and responses, on a good machine, you might have like 100 millisecond validation overhead for like complex schemas, right? If you're doing any like non-trivial validation. And remember, you know, that we're able to put an operating system, Unicraft, in 30 milliseconds on a call put. But then we are spending 100 milliseconds maybe on the way in and on the way out for every request. You know, that's kind of silly. So can we actually do better? And this is another area of my research. I'm a TSC member of JSON schema, so I do a lot of work, very heavy work within JSON schema. And one of the things I've been working on a lot is the idea of, can we compile JSON schema into something that would be like assembly or bytecode, you know, if you have used Java or something like that. Can we pre-compile the heck out of it so that then we can evaluate it with the maximum possible performance that we could squeeze out of it, given that this is such a common use case for APIs. And again, think of it as an assembly language for a schema. So in this example, I'm not sure if it's very visible, but I don't think you need to actually see all the details. But even this simple schema, properties, full type string, if we run this with a compiler, it's going to give me like 108 lines of small assembly code to run this, right? This is all open source, by the way. I have the link in there, so if you're curious, definitely go give it a shot. And well, how fast is it, right? So one of the clients I've been working with is this company called Kraken. So Kraken is an open source gateway with an enterprise offering. It's a Spanish company, very cool guys. So if you need a gateway, I definitely recommend these guys. They have a JSON schema that is 8,000 lines. Huge monster schema, extremely complex, right? So I'm showing you this big schema because we're going to be stress testing the compiler a bit, just for fun, to see how fast we can get, right? Now, for 8,000 lines of schema, let's say that we're validating a JSON document against a schema that is 8,000 lines. way more than everybody does, right? With this compiler and the technology that I'm building, we can actually do that in the nanosecond range, right? This is like half a millisecond for evaluating an 8,000 lines of schema. If you're actually doing more same schemas, you're gonna get a lot better numbers. So for example, the compiler that I have is running even on like the 20 nanosecond range for schema validation. So that's kind of cool. All of this, again, it's open source. Feel free to give it a shot. The library is called JSON Toolkit. It's a C++ library. It implements my own JSON parser. It implements my own JSON pointer parser. I have a URI implementation in there, and those JSON schema utilities and the JSON schema compiler. Yeah, go ahead.
So how exactly does this work? So this compiled on the front end and then sends the assembly code, or is it just the JSON is on the back and then it compiles on the server?
Yeah, so you can run it on both sides. I mean, for this particular example, I'm mostly talking about the API, right? So you can pre-compile, like for example, what I do in production is that you can pre-compile the schemas at build time, when you're building your API, like you can do it with some like npm hooks or something like that. And then, you will read the JSON at runtime and then evaluate it, right? So I guess for the context of the API is mostly that. Yeah, go ahead.
Is it kind of the same like using the protobuf structure?
I'm going to get into protobufs as well. It's another area that we're going to touch into. But yeah, it's something like that, right? How can you pre-compile and take a lot of complexity out so you can do incredibly optimization? It also, by the way, the compiler implements everything from draft 4 to draft 2012 with 100% score. So it's one of the most compliant implementations, way more than AJD. And it has a lot more edge cases. So it's not only faster, but very correct. And here's let's actually take like a more sane schema. Right? Let's forget about that 8,000 line monster that you're probably never actually going to do in production unless you're, a bit crazy like the Kraken guys. Don't tell them I said that. Let's take this one. Very same schema, right? We're going to validate it against its meta schema, right? The schema that defines the schemas in JSON schema, right? To make sure that the schema is valid. We do that with AJD, that's the number we get. We do that with JSON Toolkit, that's what we get, right? This is over 1,000x faster than AJD, right? Quite cool. Now, I'm partnering with the Rochester Institute of Technology. They do a lot of research. They have some good people that have done historical heavy research on JSON schema. I'm pairing with them. They're pairing with my consultancy company, and we're writing a paper where we're also we're doing mathematical proof for correctness for the compiler, and also even attempting some more optimizations. At least, which is kind of cool. So definitely look for the paper. And I'm going to probably publish it on LinkedIn or something like that at some point when I have it. But yeah, some really cool work. This is, by the way, one of the benchmarks that we're showing. Even if you compare, like, there are some, well, you probably, I'm not sure if you know much about JSON schema, but there is this library called Boon. Boon is a Rust Java JSON schema evaluator. It's supposed to be extremely fast and it has been optimized to hell. Even some of the early examples were like 3 times faster than that Rust version already, and we're still optimizing a lot. So that's kind of cool. So let's say that we have done the C++ APIs, we have done unikernels, then we actually have solved the problem of input-output validation. What's left, right? One interesting one that we can tackle is network efficiency, as you were mentioning, protocol buffers. Because the faster that an API receives data and the faster that you can send them back, the more throughput. Right? If you're actually spending a lot of time sending stuff over the internet, you're wasting time as well. And the less amount of bits that you transfer, the faster it's going to get, and you can start serving the next request even faster. So, and it's a fact, right? CPUs are going to spend millions of cycles just waiting on network sockets for the next TCP packet, right? And for example, the Node.js async event loop single-threaded model, it was designed because of this. That was the whole idea of async-based programming, so we can do stuff while we're wasting all the cycles, right? So, a waste, right? So, and not only a waste, in terms of time, but AWS, they charge for outbound data transfer. The more data that you pass over, they still steal your money. So, one common solution is protocol buffers. So you correctly said. Many people are using protocol buffers for this reason. I was at Busias, for example, this morning, also presenting. Tesla, which was also presenting in there, they use protocol buffers for all the vehicle communication because of this reason. Actually, we can do much better than protocol buffers, right? So I'm going to show you how. So this was my research at the University of Oxford. I actually won 2 awards for the best dissertation of the year around this. And what I've done is I've designed a binary serialization format compared to protocol buffers, focused on space efficiency, and it was proven to be more space efficient than any of the tested alternatives in every single tested case, right? Now, all of these papers are completely public. If you go to my website, you can find all the links of the papers and the projects. It's also all open source, so you can go take a look. I have lots of papers benchmarking this against lots of other alternatives. And you can see even from this chart, well, actually this is the old one. Yeah, protocol buffers is actually in there. It's not very efficient. You can actually do a lot better, like 3x, 4x smaller than protocol buffers is very realistic, actually. So this project is called JSON Beanbag. It's using JSON schema, yeah? Guess what? I'm a JSON schema TSC, so I use JSON schema for everything. But we're using JSON schema to derive custom encoding rules for JSON documents to create incredibly space-efficient routines, both from a computation point of view, but most importantly from a space efficiency point of view. So I originally made this for IoT. I was working a lot in IoT, but it turns out it's actually very useful for APIs too. This is one of the benchmarks I have. Again, it's all public. You can go check all of these links. In this example, we're 74% smaller than protocol buffers. And everybody thinks protocol buffers are so efficient, right? It's not. You're going to do way better. So if your clients, for example, are using JSON Beanbag, and you can opt in, if you're on APIs, you can use a content type header to do content type negotiation and pick JSON Beanbag if the client knows it, and then you reduce a lot of the bandwidth. That's kind of cool. This is one of the main papers benchmarking it. So again, it beats everybody at everything that we have tested, which is kind of cool. I won again 2 awards for this, so I'm quite proud of it. And for next time, again, it's an experiment that I have ongoing at the moment, but protocol buffers is using protocol buffers for gRPC, right? So something I've been playing around with is actually, can we do HTTP over JSON Beanbag running that straight on TCP, and then with that we kill a huge amount of overhead even from HTTP, and then we get to even the next level. But anyway, that's for next time. I think just a summary at least of what we covered at the moment. You can learn a programming language that is very oriented towards performance if you care about performance. JavaScript is not. But there are many that are high level and they are fast. Go, for example, is a great one. Rust is also a great one. You can deploy high performance APIs as unikernels. You can seek faster input-output payload validation for your APIs. And APIs spend time and money sending and waiting for data, so you can optimize for network efficiency. Yeah. And thanks a lot. Again, this is my organization. Source Meta is my company. It's a UK-based company with a lot of consultancy around high performance. All the projects I've shown you, and even some more that I haven't shown you yet, they're all open source in there, so do take a look. If you want to give us some stars, that would be very appreciated. And yeah, let me know what you think. Thank you very much. Go ahead.
Okay, can I go? First, congratulations for the presentation.
Yeah, thank you very much.
So I would like to discuss a bit the zero scaling that you mentioned. So a service that is sleeping and is waking up upon a request. So I understand that this scenario fits very well in the simple case you presented. So we have an API that is served by one service. But I would like your view on more complex ecosystems, like we saw in previous talks, either Vodafone or Telco, where, as we saw, we may have an aggregation service that calls multiple functional services. So in this scenario, an aggregation service would need to wake up, and that service would need to wake up another service, which would need to wake up another service. So does this scenario fit well in your case, or it's challenging?
I think you see get an optimization. Let's say that for all of each of these services that you're calling, you're running all of them on unikernels, right? Some of them might take more time than others, so you're at least only waking them up, all of them, by the right amount of time that you really require them, right? So even though you might keep more alive, as you pointed out, right? So it's not as like, oh, you only keep one, right? You might keep some more alive. Even then, if you take into account how we do it with Linux, you still probably get a significant boost on like a price reduction, right? Because at least you're only waking up what you need for the right amount that you need, right? So Yeah, go ahead.
Are unikernels, you can customize, you can have kernel flags, for example, an API could use something more than another one.
Yeah, you can combine them with a lot of stuff. I definitely encourage you to check the Unicraft website. They make it very easy. They are doing a lot of effort to make these extremely usable. So you can customize the unikernels even more. So for example, a very basic unikernel image, like the one that we're using here, does not even support the file system, right? It doesn't even have the concept of files. There are lots of add-ons that you can throw into unikernels. That's what they call Unicraft, like a unikernel development kit. They have lots of optional modules that you can opt in for, like for example, do you want persistence, do you want any other features, you can like mix and match. But the overall idea is that you only compile with your application what you really need, instead of always bundling the entire Linux kernel with every API, even though you probably only use a very small surface. Okay, but yeah, you can customize it well. I think you have to you pick this.
I wanted to add something on George's question about how the unikernel start up. Wouldn't we have an overhead with the application also starting up every time? Or can we take like a snapshot and...
Yes. So that's why, so on the slide I was mentioning, this is a 30-millisecond cold boot, right? What Unicraft actually does under the hood is exactly what you're saying. They actually take a VM snapshot. So that's for the cold boot. For the hot boot, which is when you actually take a snapshot and you're taking a complete snapshot even on memory of the unikernel, it boots even faster than those 30 milliseconds and you keep the state.
Okay, so can I continue?
Yeah, go ahead.
Has unikernel been used in production environments in enterprises like Vodafone or like a big scale company?
Yeah, they are used by quite a lot. Again, Unicraft is a very popular project, even as popular as being part of the Linux Foundation and sponsored by them. All of they come from academia, they have published a huge amount of papers around it. It's the most popular unikernel technology by far. So you do see quite a lot of people using it. I think for the list of companies, you could check Unicraft. They publish a lot. But you would be surprised. I think people think unikernels is a new thing. In fact, unikernels, they were invented as an idea something like 40 years ago. And there are, again, companies that are more in the cutting edge of performance. Think about big companies that are spending massive amounts of money to squeeze out as much as they can. They are using this kind of stuff. So it's not very uncommon.
Yeah, because there was a running joke when we were presenting, like maybe you are under some witness protection program. If Amazon finds out or Microsoft finds out, like.
Well, I mean, AWS, for example, they don't have the incentives to tell you how to optimize because they get money if you actually throw shitty services, right? Yeah. But again, depending on the circle you are, you can learn about all these things. I mean, they are not any mysterious. Maybe you just have to be on the right performance-oriented circles to know a lot of the tricks that people put on. But now you know.
I'm going to inject my question now because it's relevant. Why is not everyone using it, right? If it's so much better, why? What do you think?
I mean, why everybody's using JavaScript, right? It's a terrible programming language. I think, we know that we humans, we don't usually make the best rational decisions. I think, Yeah, but a lot of it's popular and that's what everybody is doing as a cargo code and then that passes over to all the juniors and, it's a vicious cycle, right? But I think you have to get out of the box to start thinking, okay, how do I actually make this faster? Right? And to even start thinking about these things, you also need to have proper background on all these things. So this is a learning curve. I think that
you need to evangelize more about this, so more people learn about it, and we start using it more.
One last. Security-wise, what's the difference between having a plain Linux kernel than it has the same features? Is it better? Is it?
Yeah, it's a good point. So there are two lines of thinking around unikernels. One of them is mostly from the security point of view, and another for the runtime efficiency point of view. Unicraft is more from the runtime efficiency. Another one that is very popular and being used by some big players right now is nano VMs. If you search for nano VMs on Google, it's another unikernel technology even more focused on security. But in general, the common wisdom is that if you run your application in unikernels, it's even a lot more secure by default. Why? Because you're taking out stuff that you need, right? So by definition, you are reducing the attack surface so much compared to a Linux kernel that you can compromise in so many different ways that in general the common wisdom is that if you already use a unikernel, it is more secure. And even then, from that bubble, there are some people that are a lot more extreme with insecurity on unikernel. But like this, again, because it doesn't do much, there are not many avenues in which you can go attack it. Then it's your fault when you get the application that will not like it.
Okay. Christos?
I would like to learn more about your development workflow from code to production.
In what way? Any specific part?
The tools, the compiler, and the libraries, how are they statically built, how they deploy to production. Because I'm trying to figure out, as I understand, this kernel is actually running by filing statically. All the dependencies of the application is fine.
Yeah, so it's okay. So there are two parts of that question. So from my own development workflow, again, I'm a C++ developer. I mean, so I'm going to be talking from a C++ point of view. I guess if you use any other of the fast programming languages, it might be different. I'm mostly a macOS user myself. I also have done a lot of work in reverse engineering on macOS internals. You can read a lot of stuff on my blog as well. But I'm primarily a macOS user. I really like macOS, and macOS has a lot of less known features that you can use for profiling and performance work. So that's what I use, but I guess like Linux is also equally valid. For actually deploying, most of the tooling, so I'm using CMake to compile everything on C++. Everything is statically linked, completely statically linked. But from that point onwards, once I compile the binary from my application as an object file, that's where Unigraph takes in. So Unigraph has excellent support for that development experience. They make it very easy, and what they have done pretty recently, for the last maybe 6 months or less, they have a Dockerfile integration. So you actually write a Dockerfile, but it's not really a Dockerfile, it's evaluated by Unigraph, but it gives you the impression that you're using a Dockerfile, so it doesn't look unfamiliar at all. But in the Dockerfile, you say from scratch. That's like the fun thing that they have introduced in there. And then you run some commands to the compilation process, and then point your application on a single binary that you have generated. So I guess a combination, I mean, there's one part that is the actual development workflow. For releasing Unigraph, it has made it like so easy.
The second part of the question. So while compiling statically, we need to compile against certain standard libraries, and usually we need to do one at the GCC or against the client version. So are there any incompatibilities? Are there any problems in the development workflow compared to if we were not using microkernels?
No, usually no. So Unigraph, they support actually both GCC and LLVM. So as long, for example, in my case on C++, as long as you're writing portable C++ and you're not depending on like Visual C++, Microsoft extensions or something like that, it's just fine. Unigraph itself is also POSIX compliant, just as Linux and many of the Unix-based operating systems, so you're guaranteed to have the exact same interfaces. So usually, surprisingly enough, you run into extremely little problems, if any, and you can compile a huge amount of stuff. Unigraph also in their org, they maintain like a massive list of stuff that they have ported. They have, for example, pre-made unikernels for running Nginx, for running Redis, for example, for running a lot of stuff. So maybe you don't even need to do it yourself. They have like an entire thing of this stuff that they compile. But this, in my experience, again, you stick to portable C++, it's an easy ride.
Other questions? Nothing.
So you talked a lot about the runtime efficiency. So what about the memory efficiency in this scenario, this particular scenario, specific for the precompiled schemas and for production APIs that requires a lot of memory, a lot of requests per second?
Right, yeah, so there are three parts of it, right? From the unikernel point of view, you can get your application running, with the application that I wrote at the beginning. If you prepare that with unikernels, you can get an API responding with like 2 megabytes RAM max of usage, right? For like a very basic case. Now, if you add the compiler does have some overhead during the evaluation process. It's something that we're going to be covering a lot more detail on the paper, but we have been putting a lot of effort to make the memory usage of the compiler completely flat, right? And we can guarantee some level of utilization, and that utilization is also like in the 1 megabyte or 2 for even compiling things like this 8,000 lines of schema. So memory usage is extremely low in the compiler. Again, I don't think I can show you something right now, but I think if you eventually read the paper that we're going to publish, we're going to have a lot more details. But then the third layer, which you're asking, is also your application, right? And on the application, I mean, nobody can save you from that. I think then it's your code. And then you have the responsibility of making sure that whatever you do on top of that base, you make it in an efficient way, right? Because again, even if you use C++ and use unique kernels, if your application is badly designed and you're doing weird things that consume a lot of unnecessary RAM, then nobody's going to save you from that, right? So you have to be conscious about on the entire stack, otherwise you might defeat the point, right? But it's more like performance education, right? If you learn how to use a lot of profilers and tools and how to do observability of your projects, you can make sure that you never do something with it.
Other questions? Go ahead.
Could you please briefly describe the architecture? Say how do you deploy this API, say in cloud, including API gateway, maybe some load balancer, and how would you deploy as unique kernel applications to get the maximum advantage?
Yeah, so you can do what I do personally. Again, there are more ways of doing it if you go and check out the Unicraft website. But I'm actually deploying on AWS, right? Same thing, because on AWS, nobody forces you about the operating system, right? If you go and take an EC2 instance, you can have an EC2 instance running on bare metal or something like that without any operating system and loading the unikernel right away, or you can have your own KVM or something like that running the unikernels for you. So that will be more like a hands-on approach if you want to go and do all of that yourself. Other than that, what I use the most is so Unicraft itself. They have a paid offering that you can subscribe to. It's very cheap, so I have a plan on that. That's why I used to run my own production stuff. And they essentially manage the unikernels for you on top of AWS. So it's still AWS, everywhere. But they manage all of the infrastructure required to do upscaling, downscaling. They provide like a Kubernetes-like experience for Unicraft on top of AWS. So if you subscribe to that, which is a generous plan, they even offer a free plan, they take away even all of that for you. And for you as an end user, it's not that different than you deploying a container and then running out of a managed Kubernetes cluster. You get the same experience. But you can still do it yourself if you want, but it has drawbacks as well.
Other questions? Actually, I have one more question. Right? C++ is quite an old programming language, been used for quite some time, and especially for desktop applications. But indeed, taking one question that George asked before about, let's say, an enterprise setup, or where you want to have a lot of use cases like, I don't know, file management, PDFs, integration with SOAP. With all the other languages, there are ecosystems of libraries that you can use for PDF handling, or creating a PDF template and filling it in, right? For example, which is, or they create SOAP client. In C++, how is the ecosystem on all these things?
I mean, of course, I'm biased as a C++ developer. I've been doing C++ for a very long time, but I would say that the ecosystem is way beyond all the other ecosystems, right? And the reason I say that is that if you think about most of the software that actually runs the world right now, thinking about banking applications, thinking about everything else, usually down the bottom, it's either C++ or C, anyway, right? Say we're talking about Node. If you're talking about Node itself is written in C++, right? So it even goes back to that. Swift, for example, programming language talking about desktop apps, implemented in C++. Linux kernel is implemented in C, right? So at the end of the day, everything is actually available mostly at that layer, and then it's actually exposed to the other one, right? So they usually, other like higher level programming languages, they inherit in a way the ecosystem of C and C++ because they just buy it, right? But that said, if you're not very comfortable with C++, which not everybody is or wants to be, and it's a complex language, it has very powerful but very complex as well. That's why some people prefer things like Rust, right? Because Rust, it has a performance capability of C++, and it has a developer environment that is a lot more popular than more modern quote-unquote ways of doing things like a package manager, like NPM and that kind of stuff. So that's why I mean, I don't recommend C++ necessarily, right? Maybe just if you want. But there are many other alternatives. Rust being a good one. Sig, again, very high level, is getting a lot of popularity. And even Go, right? Go was designed by Google to be easy to use. That was the main point. And it is very performant as well. So you have a lot of options. So I'm more presenting my own.
In this scenario where your application, that's the most of the time the case, where your application is a composition of different libraries, right? You want to use all the libraries that you have and do your business case, right? That's 90% of the software built. If you have all these dependencies in your application, does it affect when you want to deploy it as a unit graph? Will all these dependencies that you may want to use are compatible and compliant with how your application is to be to run or so fast on the...
I mean, from the compatibility point of view, I wouldn't worry about it. Again, Unigraph, they support all the major compilers and they're entirely POSIX compliant, so usually you run stuff for sure. But again,
one library that's going to break my...
I haven't seen it myself, but then, I mean, there's always the case that like nobody's going to save you from bad code if you're consuming a library that is badly designed, right? And it has its own load for X reasons. And there's no silver bullet that is going to make that faster, but I think that's more like basic dependency responsibility, right? If you make sure that your dependencies are well done and they don't do insane things, then you should be fine, right?
Okay,
cool. Anyway, I'm going to be around for pizzas and everything, so if you want to see any more stuff, thank you.
A few seconds, because the pizzas are not also here yet. So you will have to wait if you are hungry. Perhaps the delivery man also will be late on the rain. Thank you all for attending. We plan to increase the frequency of the meetups. So you can expect an announcement for the next meetup around